Welcome to Unite Now, where we bring unity to you, wherever you are.
All right. It looks like it is time, so let's go ahead and dive right in, everyone. Thank you for coming. Big welcome. I'm looking through the chat right now, and everybody who's attending, it looks like we have quite a few familiar names, and it looks like we have quite a few new names as well. So for those who are just getting here for their first Unity Learn Live, welcome. And for those who are coming back for a second, a third, a 10th, we certainly see quite a few familiar names. So big welcome back to you guys as well. So you are here to learn about particle systems. What exactly does that mean? Well, Unity, we're here to learn about Unity 3D, obviously. And within that, they have a really special tool called the particle system. So we are going to learn about how we can create different effects such as rain and snow as well, and fire and smoke with these particle systems. So if you haven't already, let us know where you're tuning in from in the chat. And if you're planning on following along today, go ahead and start downloading the particle systems assets at the bottom there. James, thank you for dropping those in. And let's go ahead and dive in. So who's the voice? Tim here, calling in from Florida. Actually, usually I'm calling in from San Francisco. Here for a few weeks. And I am the director of design at Kairos XR. That is a development agency for occupational training solutions where we use Unity as our primary development tool. So I work alongside the Unity team as well, very closely, leaning more towards design. And joining me today, we have some really awesome Unity developers as well. We have James, Brian, Kushbu, Aaron, and Daniel as well. So for those who are coming back, again, you know that the main advantage of, or the primary advantage of these sessions is access to the instructors. And having effectively treating this as a session to have all of your questions answered. So with that said, feel free to ask any question. Feel free to ask any question that you have, and we'll get to those questions as soon as possible. So how do these sessions typically break down? Well, we start with a little bit of housekeeping, a quick overview. We will be working in 2019.4 today. We'll go over some of the session guidelines, and then we're going to go into some of the tips and tricks getting started with particle systems. Today, we have an hour and a half together. We have 90 minutes, not 2 hours. Typo. We will be going through we'll be going through 4 distinct challenges here with a little extra challenge in the end, time permitting, of course. And then we'll wrap up with a few minutes in the end, talk about next steps and additional resources as well. So we recommend this Zoom layout. You can keep the chat in the upper right. That's actually how I do it as well. So I can keep an eye on all the questions, the comments coming in, and then expanding the screen or going into full screen, I should say, for the rest of the Zoom window. So you can bounce back and forth to your Unity window as well. And again, how do we make the most of these sessions? Well, I did mention when introducing the other instructors on the call, we are direct access to get all of your questions answered. So we recommend to get the most out of these sessions. We recommend you follow along. You have a Unity window open. We'll interact. We'll go back and forth. I'll demo a little bit, then we'll work together. The TAs will help you along the way as well if you get stuck. But either way, we are here as a resource for you. Yeah, James.
Hey, Tim, I don't think you're sharing the right screen because we still see the title screen.
Oh, all right. We will. All right. Thank you, James. Thanks for hopping in there. It looked like it was, yeah, wasn't sharing. The share was locked. Thank you for hopping in. So which slides were I talking, was I speaking to there? Well, again, here's my face. I'm very, very sorry for that, everyone. So this is me. I'm Tim. Here are our fabulous TAs. This is the slide that I was referring to. And again, we will be working in 2019.4. We'll start out with a few of the tips and tricks in the particle systems. Again, this is the slide I was just speaking to before. And here are the 4 distinct challenges that we'll be going through. So we'll be setting up particle systems, we'll be setting up smoke effects, fire, rain, and actually we'll be setting up snow as well. And then we'll wrap up. Lastly is the actual format here. So typically I'll go through a demo You can watch that, and then you will actually follow along, and you'll do, and then we'll explore together. Cool. Here's the Zoom layout that I was so thoroughly describing before. And here's the last slide. If you're new, you'll be able to catch up on the recordings later on. All of these sessions are recorded, so we'll be distributing that after the session as well. So if you don't want to follow along, that's totally fine. You can just watch. Some of us come here just to watch. Others come here to work together and collaborate on this. Again, this session is here as a resource for you. One last note there on that slide before we keep on going. If you look at the bottom of your Zoom screen, there is an icon for the Q&A, and you'll see that the Q&A feature is a Q&A button. Go ahead and drop all of your questions in regards to Unity or the topics that we're covering in that Q&A window. And then TAs will be able to go through and get to those as soon as possible. We tend to have a pretty active chat channel, as you can see from all the new messages. So it's possible that your questions will get lost in there. So go ahead and use that QA button at the bottom. All right. We made it through. I wasn't sharing the entire presentation, but we made it through. And now let's go ahead and let's start diving in. I mentioned that in this session, we're going to be working through together on a few examples of different use cases for the particle systems. Again, we'll start with snow, move into smoke, move into fire, and then rain. And then in the end, we'll actually work on a few gas planets, if you will. So we'll use the sun as an example, where we can really make planets out of, or really any planet out of the particle systems too. So time permitting, we'll dive into that. But for sure, we will hit these four. And as always, we want to create a space for you to actually set up the project. So if you haven't done so, go ahead and download the asset package from Learn. Again, let's make sure that, just taking a look at your chat to make sure that the assets are in there. James, if you wouldn't mind dropping those assets in there one last time, it'd be appreciated. Thank you. And once you go ahead and download the assets, go ahead and open up a new Unity project. Again, we'll be working in 2019.4. Extract that package and import it into Unity. So as you're doing that, as you're downloading it, let's go over some of the basics. So why do we care about particle systems? Well, it's a really, really handy tool for special effects. And now, with the release of the Universal Render Pipeline and the High Definition Render Pipeline, Unity has a new tool called the VFX Graph, which is a new particle system, or effectively a new particle system, that renders out on the GPU, which means that now we have access to millions of particles rather than thousands. But in this case, we are starting with the first particle system. And this particle system is capable of rendering out thousands of particles and is locked to the CPU. So that's the distinct difference between the VFX graph and the particle system. So VFX graph, GPU, particle system, CPU. Why does that matter? Well, when it comes down to deciding on which one you should use, if you require an effect with a ridiculous number of particles, then certainly you should lean towards the VFX graph. But with that said, if your project is GPU bound, then you may not have that as an option. Thus, you'll need to use the CPU to render these out, or the particle system in this case. So common use cases for the particle system, well, we can simulate liquids and smokes and clouds, flames as well. If you're in the gaming world, you can simulate magic spells and a whole other set of effects as well. So this is why we're excited. And it's all based in the editor as well. So I'm going to go ahead, I'm going to hop into my editor, and we will start creating the snow particle. How are we going to do that? Well, we'll first add the particle system to the scene. And again, if you work through the challenges ahead of the session, these are going to look very, very familiar. We're going to work through those challenges together, but of course we will elaborate and we'll build on those as well. So we will, again, we'll open up our new scene, we'll add a new particle system, and then we are going to modify a few of the general particle settings as well, parameters, such as noise, collisions, emission, and shape. All right, so I'm going to create a new share here. Go over to my scene. All right, and here is our scene. As you open up your project, you're gonna have a few different scenes that you can take a look at. Again, just double checking to make sure that we are on the right one. Cool. So as you open up your project, you'll have a scenes folder, and you can open up starter, or you can open up examples. And as a first step, again, I'm in starter. I'm in starter because that's where we're going to be building out the majority of our particles, actually all of our particle examples. However, a really great way to get started with particle effects, or the particle system, is by looking at professionally done particles or particle systems. And one way you can do that is just downloading the Unity asset pack, the particle asset pack, on the asset store, or now the package manager if you're in 2020, and taking a look at how some of these were done. So if we click on one randomly, we'll see that we have these bugs flying around with the tails as well. So we have the fireflies, and then within the inspector, we can take a look at all of the different parameters that they're using and engaging to create these effects. So you can see in the renderer, they're using a firefly texture, or excuse me, a firefly material. We have a trail material as well. Okay, if you're not as excited about that, we can look over at another one. Looks like we have some pink slime here, or some green slime, some more slime. And you can see that you have all of these different use cases and examples of particles. And as we go through them, we can click through all the parameters and see what exactly did the visual effects artist use or do to create these effects. All right, so that's the first step. As we're going through the project, you've now imported the package, you are in the examples, and you're exploring some of the different features here. If you've already explored, you found a few that you already liked, we can hop back into the starter scene, and let's go ahead and start creating our snow effect. So you can see here I have a few other particles as well. These are just from before when I was playing around, but let's go ahead and just create our first particle. Cool. Once you create a first particle, let's go ahead and drag it in. Another hack as well, if it spawns way off just in the camera's field of view, you can select it and hit Control-Shift-F, and that will spawn right where your camera is as well. As a pro tip, it becomes a little cumbersome to try to use the gizmo here to rotate, so I highly recommend when you're working with particles, just use the rotation transform values. All right, so we are creating snow. So what does that mean? Well, the first step, again, we've added the particle to the scene, and let's rename it to snow. And now we're going to modify the first set of parameters here, the first module, if you will. And the first step is reduce the speed to 0, because we don't actually want anything flying up. As you can see, reduce it to 0. And then we're going to increase the gravity modifier. We don't need to increase it all that much. We're just going to increase it to 0.1 so that the snow starts to gently fall. And I suppose we're starting to get the right shape. We're starting to already resemble some snow. For those who are coming from very snowy places, which frankly, I'm not sure, except for Antarctica, where in the world would be snowing. However, you can start to see some of the similarities there. So what's the next step? The next step is to change the starting size. These are pretty big snowflakes, so let's make those a little smaller, and you can go over to the start size, and we can either scrub that down or set it a little more precisely. We're going to set it to 0.2. All right, and then the next step, how do we actually expand the area? I mean, this is a very, very small cloud if that is the only area in which it's snowing. So what we can do is expand the emission as well. Or excuse me, we can modify the shape. The shape here by default is set to cone. And we can change this. We can, let's say we wanted to expand it across the ceiling here. Again, if our goal is to expand it across the entire ceiling, how do we do that? Well, we change the shape from a cone to a box. And then from there, we can modify the shape by adjusting its scale. So let's go ahead, we'll tighten it up a bit. And now we have our snow coming off the ceiling. But of course, snow doesn't actually come off the ceiling. So what we can do is let's pull it out. Let's bring it up and let's expand it across the entire top. Oops, wrong value. All right, so what I just did was I pulled the particle, I just manually brought it up and very imprecisely, might I add. I brought the particle system so it sits above next to the roof and then expanded the box because we're now emitting from a box shape. Cool. All right, so how do we get more? How do we make this a storm? Well, we can increase the rate over time, so we're emitting more. But as we go up, each second, we're now telling it that the particle system, for every second, we need to emit another 55 particles. And that's quite a bit, but we could also make it larger blizzard. And eventually, we're going to cap out. So how do we increase the number of max particles in the scene at once? If we look back up at the first module, you'll see that there is a max particles parameter. And we can increase that. And let's go ahead and increase that just to 3,000. Again, relatively arbitrarily chosen right now, but we're here just to explore. All right, and when you are ready, let's go ahead and hit play and let's just take a look. How does it look? As you hit play, you'll find that you already have player controllers attached. You can use WASD or WASD and your mouse as well. Yeah, we have something that resembles snow. But as many of us know from living in a snowy environment, snow does collect on the ground unless it's a really, really hot ground. So let's go ahead and update a few parameters so that it collects on the bottom. All right, so the parameter that we are going to explore now is collision. So let's go ahead and update the collision, or excuse me, enable the collision. We'll enable the collision, and we're changing the type from planes to worlds. And now it's important to know the difference between world and planes. If we keep it on plane, then we can very precisely choose which plane the particles will interact with. However, if we move to world, then it will interact with all of the game objects in the world based on the bounds and geometry. And as we make this change as well, you'll notice that a bunch of other parameters pop out. So what do these parameters actually mean? Well, the ones that are important right now will be dampen. Because if we were to, let's go ahead and hit play on these, you're going to see these bounce and have really sporadic behavior that quite frankly doesn't look like snow. I don't know about you guys, I don't think I've ever seen snow that bounces quite like this. So that's not our desired behavior. But what we can do is reduce our bounce all the way down to 0 because we don't want it to bounce. And we also don't want it to roll. These aren't marbles, right? These are particles. So it's supposed to be snow. So let's go ahead and increase the dampen to 1. And now they're stopping and they're not moving. And that's a lot more accurate. All right. So the last bit we're going to look at here before moving on to the next challenge is the noise. So we can add some Perlin noise and other types of noise as well to create some kind of wind effect as well. So as we know, when it snows, typically there's a little bit of wind, and snowflakes, unless it's really, really heavy snow, don't necessarily fall directly to the ground. So how do we add the effects of a little bit of wind and that movement? Well, we can add the noise. So go ahead and toggle on noise, and we can increase the strength if it's a blizzard, or we can decrease the strength just so that there's a little bit of character as it's falling. Awesome. And that is our intended effect. That's all we need to do to create snow. And as you can see, it really wasn't all that complicated. We didn't need to animate anything. We didn't need to customize any features. So this is just a nice little warm-up activity as we dive into more particle effects. All right, so let's go ahead and kill that for now. Now I'm going to take a look at the chat. hop back to the presentation before we continue. I just want to make sure that we are doing okay. There aren't any raging questions or perhaps any notifications that I'm in fact not sharing my screen. All right, so we have a few questions there. Also, Mendisa, you pointed out, thank you. Yes, in the Southern Hemisphere, you're absolutely right. It is winter. So listen, I'm in Florida right now. It's ridiculously hot. So I'm a little tunnel visioned here, but yes, in the Southern Hemisphere, it is winter. So hopefully there's some snow down there as well. So we are creating a simulation for them, for our friends coming from the Southern Hemisphere. Yes, so the next question there is there any way to change color? Yes, absolutely, there's a way to change color. This would be quite limited if there weren't, so let me go back to the project. So how do we change color? Let's go ahead and play. Well, we have a start color here. We have a few ways in which we can change color. We can either modify the start color. So let's go ahead and just create blue. Actually, we'll need something a little more apparent here. So we'll go ahead and make it red. And as we look at these, we will have some embers coming down. We can also randomize. I mean, so your next question may be, okay, great. So we can modify the start color, but what does this arrow do right next to the start color? And we have a few different drop downs here. We can make a gradient. So if we wanted to, well, let me start with the other ones. So we have random between two colors. So random between two colors will automatically randomly assign a color value to each particle between the two color values. So if we go random between two, some of them may be white, some of them may be red. And then random between two gradients is the same thing, because we also have the gradient values that we can assign. For instance, if we wanted to start as a red, and then we want to add another gradient, and that gradient, another color, and that may be blue. So then we will have some of the particles blending between, so eventually hitting that nice purple. And then we have a random color as well. So perhaps you just want to assign a random color to the particle somewhere in this whole gradient. So you have quite a few options. And right now we're just playing around, right? Right now we're just exploring. But what happens if you want to create embers from a fire or sparks coming from a fire? And each spark should look a little different. Some are more orange, some are more yellow, some are more red. That's when the gradient becomes a little more interesting, or perhaps random between two colors becomes more interesting. All right, so let's go ahead and keep on moving on here. There are a few more important parameters within this first module. There is the simulation speed. So if we want everything to move really, really quick, this could be an interesting effect as well. If you're say building out a game, or for whatever reason, when you go to a particular area, you want the effect to accelerate for whatever reason, you can use a simulation speed. Additionally, let's say that everything is almost perfect in your particle system, but things might be moving just a little too fast. Well, we can reduce the particle speed as well, or the simulation speed as well. So we can reduce it to half the speed, and then things move even more slowly. There are a few more important parameters here. For instance, duration. Right now we have looping, but if we were to turn off duration, then we could set the amount of time that the particle system will emit particles. Versus looping, where once it gets to the end of the duration, we set it to 5 seconds. Just by default, it's set to 5 seconds. But if you'd like the particle system to keep on looping and keep on moving, then we can hit this looping feature. And then pre-warm is the last important one that we'll keep an eye on before we continue exploring additional exercises. So pre-warm, as you turn on particles, if you keep pre-warm off, then they will start from the origin point of the particle system. However, and let's restart. And you can see now, because the origin point is at the top, the particles will begin to fall. Let's go ahead and hit restart with the pre-warm on. And you'll notice as I hit restart, the particles are already landing on the ground. Why is that? Because it pre-generates the particles and it pre-calculates where they'll land. Oops. And now I've lost particles. Here we go. Cool. So let's go ahead and move on and let's create some smoke, because now we're going to use textures and we're going to create more realistic looking effects. We can reset this. Let's go ahead and reset it back to white because it's snow. Cool. I'm going to toggle that off. Why? Because performance does matter. And eventually you're going to have so many particles in your scene that performance will take a hit. All right, so the next step here is to create some smoke. So let's go ahead and we're going to follow this very, very similar steps, but instead of making them fall, we're going to make them rise. So how exactly are we going to do that? So yes, we are going to create a new particle system. We will modify a few of the general particle settings, again, in the same module where we are just working. We're going to modify the emission and the shape again. But this time we're actually going to modify something called the renderer, or the renderer module, and the texture sheet animation. So we're going to move into new territory here. We will add textures to each particle, and then we're going to be using a texture sheet to animate different effects so that each particle doesn't look exactly the same. And yes, we will use some noise again as well. So I'm seeing a few comments here. Somebody says, you can totally see the potential for you just becoming obsessed with this. It's a really, really deep space. And this is fun for hours, effectively. And that's really the best way to get better at this, is continue to dive deeper and just continue to explore, dissecting the particles that exist on the asset store, and then continue to play around just with your own exploration. So let's go ahead and create another particle effect, particle system. And again, it spawned way over there. So let's go ahead and bring it back. I'm going to position it right under this light. So remember our trick, Control-Shift-F. So we could spawn it exactly where we'd like to. And in the next step, we're actually going to create some fire. So we will be placing the fire directly under the smoke. All right, so we have our particle system, and the first step is to make it kind of look like smoke with a color. So let's go ahead and take a look at this start color and make it a smoky gray. Could even make it look kind of a brown. And let's decrease the start speed and increase the start size. All right, so right now, we're just ripping through the particle system. We're not very precisely creating any of the target effects, and that's totally okay as well, because so much of it is more of an art rather than a science, and that's the beautiful part of working with VFX. All right, so we're not going to touch the duration. We're going to make sure it's looping, and let's make sure it's pre-warming as well, because why not in this case? We modify the start speed. We modify the start size. That actually might be a little too big, so let's go ahead and bring that down just a little bit. And let's take a look at the emission now. We would like to increase the amount of particles that are emitted at once. So let's double this. Again, relatively arbitrarily chosen. In the context of the entire system, or the final piece, if you will, we found that 20 starts to look a little better. But again, this is just something that you can play with. So we want every second the particle system to emit 20 particles. And now let's modify the shape. So the shape by default is set to a cone, but let's close out that starting point, make it a little narrower. The angle, by adjusting the angle, so as you can see with the blue icon or the blue gizmo here, if we adjust the angle, if we increase the size of the angle, we increase the direction that the particle system may emit particles. And if we close it out, then eventually it becomes more of a cylinder. And we can reduce the width of that cylinder by adjusting the radius. So we're going to bring that radius down to 0.2, and then the angle is going to be, well, it doesn't need to be 0. Let's go ahead and just make it 0.5. Well, let's make it more than 1, because clearly that doesn't have much of an effect. So then it's moving out a little bit. All right. So we have modified the emission, we have modified the shape, and let's go ahead and modify the renderer. So I mentioned that we have a new module that we're going to play with, and that is called the renderer. So at the very bottom, you'll find the renderer module, and this is the module responsible for housing all of your materials. And we already took the liberty of creating material for you. It's of type, I believe it's called smoke light. Yes. You'll find that if we zoom into smoke light, it looks like a texture sheet because it is a texture sheet, and we're going to talk about or I'll show you how to adjust this in just a minute. But let's find smoke light really quick so we can take a closer look at the material. You'll find that smoke light just comes, it's one of the Unity standard asset materials, or rather in their standard particle pack. They built it for us. The shader in this case is just a standard surface shader, but it's a particle shader. So we need a little special for us. But of course, you can create any shader or any material and add it on there as well. So let's go back to our particle system. I forgot to rename it smoke. So let's go ahead and rename it to smoke. All right, and let's go ahead and kill the texture sheet animation. So the next step is to move up and enable texture sheet animation. And right now, when we enable it, it's set by default to tiles 1 by 1. And this particular texture sheet is 5 by 5. So go ahead and update that to 5 by 5. So the particle system loops through the texture sheet and eventually hits all 25 assets, or excuse me, textures, or sprites. All 25 sprites. Found my word there. All right, so now you can start seeing that we're getting a little bit of interesting behavior. It's starting to look a lot more like smoke, and it's a little easier to see when we actually move it out. Look at it from, well, I was going to say when you look at it against the sky, it's a little easier to see, but it's actually not the case. So we'll leave it right there. So, and let's make the final adjustment and create a little bit of noise so that we're not just having it go straight up. And yes, when you increase the strength, it's going to fly all over the place like it's in a vortex of sorts. But let's reduce that down to something simpler like 0.5. And let's go 0.1 because 0.5 is way too much. Cool. You know, we could even bring this down a little more as well, 0.05. Great. And now we're seeing some of the more unpredictable behavior, which is what we like in smoke. Before we take a step back for a few minutes and let you guys catch up and continue to explore on your own, let's go ahead and look at a few other modules such as rotation. So we have start rotation. And if we set the start rotation, then we can make the smoke rotate as it continues to move until it disintegrates or until it deactivates just naturally through the particle system. So when creating smoke or something that's relatively transparent, say mist or fog or steam as well, typically the start rotation value is used. So we can create, again, we can really crank it up if we want to create a lot of rotation as well. A little harder to see because it is relatively transparent. But again, that's how you would create some kind of twisting effect within your smoke. And you may start noticing that as the smoke reaches the end of its life, or the particles reach the end of its life, they just disappear. And that doesn't look all that great. So how do we make the smoke just fade? Well, we also have color over lifetime. So let's look down, look through our list. As you can see, there are quite a few modules that we can add here. And again, it's all about familiarity right now, not mastery. But after the session, I recommend you go through and just start playing around with the different effects and see what you can create. So here we are, color over lifetime. So let's create that color over lifetime. So in the beginning, we can start is, or we're going to look at the alpha on the top. So the color is at the bottom. We're going to take a look at the alpha. So in the beginning of the particle's life, the alpha will be 255 or full. And then let's move towards the last quarter. We'll also have a full alpha, but let's go ahead and add one last tab at the top so we can reduce the alpha down to 0. So now, as a particle nears the end of its life, the alpha starts to become 0. And again, we can play around. We can play around with these as well. Move this around. If we want a sudden drop, similar to how we had before, we can bring this middle tab all the way to the right. Or if we want to have a more gradual disintegration or evaporation, if you will, then we can keep it close to the middle. Cool. So now we're seeing more of that fade. We're not just seeing a hard stop in that case. And this is something that we like this. This is what we're going for. All right, so I'm going to take another look at the chat here, make sure we're still doing well. All right, it looks like we don't have any major burning questions. Thank you to the other instructors for handling those. All right, so looking back through the chat, it looks like we do have one question in regards to particle systems for UI. So there are, there are a few different tricks you can use there. We won't have a session. The question is, will we talk about particle systems for UI and how to render particle systems over the UI? Dennis, if you don't mind, please drop that in the QA. We can provide a little more documentation there. But there are a few different workflows that you can employ to bring particle systems into your user interface. But it's very, very possible as well. Those just be 2D, for instance. All right, I'm going to hop back to our presentation. So we created smoke. Smoke flies up. We created snow. Snow drops down. So let's go ahead and change it up a little bit and create some fire. So how are we going to create fire? Well, we're going to follow a very similar workflow with the texture sheet animations. But instead of having the particles fly around, specifically because of the noise and all that, we will be using noise. But we're not going to, the particle is not actually going to move. It's just going to stay in one place. So there's not going to be any movement. It's just going to flick on and flicker off in this case. So we will be modifying the emission. We'll be modifying the shape as well. The renderer, yes, because we need to get that texture in there as well. We bring in the texture sheet animation. We'll be using a flame texture sheet animation. And eventually, we're going to get it looking just like the fire does on the right there. All right. And before we continue, we just went through 2 challenges relatively quickly. I just want to do a quick gut check. How's everybody doing on speed? I'm taking a look at the chat. Does anybody want me to slow down? Should I speed up? Is it just right? And if it's just right, either mention that or don't mention it, and I'll just infer. I'll infer that. Cool. All right. All right, so it looks like we are doing well on speed. I'm getting a few mentions that we should slow down just a little bit, which is totally fine. I can slow down just a tad, but we'll keep the speed relatively consistent. So let's keep on moving here. All right, so again, for performance reasons, I'm going to kill the smoke, and then let's create our fire. So effects, particle system. Our particle system is way off in the distance there. So let's go ahead and bring that back. This is our new particle system. Control-Shift-F. Or if you're on a Mac, Command-Shift-F. We'll rotate this around, and we're going to drop it down the ground as well. Because typically smoke is connected to fire in some capacity, so we're going to drop this particle system at the bottom. Let's rename it to fire. And just so I can clean everything up, I'm going to add a new empty game object and just drag the other stuff in there. All right, so the first step. What is the first step? So let's start with that color. low-hanging fruit. Let's make it kind of orange because fire tends to be orange or yellow. Let's make it yellow. Great. And I mentioned that the particles, by default, are flying everywhere, right? But we actually don't want that in this case. So we can turn on pre-warn because when we actually start the effect, we want it to be running. And we want to create that flicker. So we want the particle to come alive, and then really, really quickly, we want it to die and then get replaced with the next particle. So we're going to reduce start lifetime here, which, as we can see from the hint, we can reduce start lifetime to control the age or the time that the particle exists. We're going to control, or we're going to bring it down to 1. So we get some kind of flicker. Cool. Start rotation actually doesn't matter in this case. Gravity modifier doesn't matter. We're going to keep that at 0. And let's go ahead. We can change the start size as well, just a little bit, so it's a little larger. Let's go ahead and bring it to 2. And I'm going to update the start lifetime to 0.05. Cool. Yes, that's quite intense. We will update that momentarily. Not to worry. And that start size does not need to be 222. Great. Okay, let's keep on moving down. So the next step here is to modify the emission. So first of all, let's make sure that the max particles should only be 1 because we only need 1 big flame at one time. And then how many will emit per second? Well, we can keep that at 10. We'll modify that slightly in a little bit. But the big item here is to modify the cone or modify our shape. So we can change the shape, and let's change it to circle. Taking a look at the shape, we brushed over this in the last one. We went through it very quickly with the snow one as well. But you can see when you hit the shape drop down, you enable shape, and you have quite a few different options. You have cone, you have sphere, you have box, you have edge. And then you look at something like mesh render. And what happens if you have a 3D model and you would like particles to emit from the entire model? For instance, if there's some kind of energy surrounding it, you can use a mesh renderer as well and bring in that mesh renderer. But in this case, we're going to reduce that angle. We can keep it a cone. We'll reduce the angle. We'll reduce that radius. Cool. And now we're starting to see something that is less all over the place than it was when it was much larger, but something that's more closely resembling a fire. You'll notice as well that it's turning off. Why does it continue to turn off? Well, because we didn't turn on looping. So let's make sure that looping is turned on as well, and then we don't need to worry about this duration. Alternatively, if we keep duration on, or keep looping off, we can see that duration will kill the particle system after 2 seconds. So let's just keep that on looping at pre-1. All right. So let's keep on moving through. The next step will be to bring in our texture sheet animation. So let's go back down to our renderer. And let's make sure that we bring in one of our materials that we pre-built this for you. Let's go large flame. Large flame 1. If we take a look at large flame, it has 1, 2, 3, 4, 5, 6, 7, 8. This is an 8 by 8 texture sheet. So when we go up, yes, you guessed it, we're going to go back up to texture sheet animation. We will update this so that the particle system moves through all 8 rows and then all 8 columns individually. And now we're starting to see something that resembles more of the flames. There's still work to be done. So this is not our final result here. But we're starting to see the flame shape, as you can see. So let's go ahead. Let's keep that down. We're actually going to keep it down to the lifetime as it was before. If we want to slow down the flickering as well, we can reduce the simulation speed. If we want to create more flames, we can increase max particles and the emission as well. And now we're starting to see something that resembles flames a little more. And if we turn on the smoke as well, let's make sure that the smoke is actually above the flames. Now we have a nice little particle system combination. All right, so the flickering is a little intense, and let's turn it over to you guys. So in the next few minutes, go ahead and play around, and the challenge here is to play with the parameters, and let's see if we can figure out how to reduce the sporadic behavior of the fire. Let's see if we can keep it closer in just one spot. And in the meantime, I'm going to keep on playing around with it myself. So the first step here when we're thinking about other parameters that change. Well, if we know that the sporadic behavior seems to be from shifting the x and the y axis there because it's rotated, what we can first do is take a look at the shape, and the shape seems to be a little off. As you can see, if the shape were wider or if the radius were wider, then the flames would be popping up all over the place. So if we reduce it all the way to the bottom, 0.0001, then we have a much more controlled flame. If we want it to be raging, let's say this is at the end of a torch, and then we can increase the emission as well. All right, so this is starting to look more like a gaslit stove than anything. Certainly not somewhat of a controlled burn, if you will. And now we're getting the target effect that we were looking for. And now we have fire. So I'm going to take a look at the chat here and just make sure that nothing is blowing up. You guys can still see my screen. That's a total win. All right, and it looks like we don't have any raging questions, and we will keep on going. All right, so we do have one question. How processor intensive is all of this? So it's very difficult to say, oh, it's really processor intensive, or it's not processor intensive. There are certain areas that are going to be more expensive than others. So the more materials that you have, typically the more expensive it's going to be. The more particles that you have, the more expensive it's going to be. The trick here to measure your bandwidth for your specific project will be to use the profiler. And we have an optimization Learn Live as well, where we teach you how to learn the profiler, but it's a really handy debugging tool as well to measure performance throughout your project. It also determines whether you're CPU bound or GPU bound. And if you have a full project and you're rendering too many assets, for instance, again, we spoke to this in the beginning, but that's when you might use a particle system. Now, if you look at the profiler and it looks like you have too many physics calculations going on, or you're CPU bound, your project's locking up and you're CPU bound, then that's when you need to reduce the number of particles in the scene as well, or reduce the number of materials that you're using. So if you'd like to dive into that, Matthias, as well, we're certainly happy to dive deeper into it. Let's follow up offline afterwards, so we can, or once we get to the end of today's session, and we can dive deeper in the designated QA time. Looks like we have a request to go over the actual flame part of this. So remember, in order to achieve this flame, we look at the renderer. So close these out for a little more simplicity. The first step, it's a two-step process to achieve that flame. So the first step is to add the material, the large flame 01 material, which is a material pointing towards a texture sheet, an 8x8 texture sheet. So go ahead and add the large flame material to this perimeter. And secondly, in the texture sheet animation, that's when we actually activate the animation itself by updating the tiles so that's 8x8 instead of the default, which is 1x1. Which obviously doesn't work. which is why we keep it at 8 by 8, which matches the texture sheet. All right, so let's keep on moving on here. We're gonna hop back to the presentation. All right, so we actually had one of our questions, can we create rain? The answer to that question, which I saw in the chat a little while ago, is yes, we can create rain, and we are gonna do just that right now. So let's go ahead and take a look at it. We are going to modify some of the general settings, just like we have been, such as the color. We will be playing with the renderer as well. We will add a rain texture. This concept of vertex systems, we're going to enable it because the shader provides this parameter. This is not standard. It's also a more advanced feature, so we're not going to spend too much time on the vertex systems. It's also not required to achieve the rain look. Yes, we will modify we will configure the shape as well and the emission. So let's go ahead and create this shape or the effect. All right, so performance, again, let's go ahead and kill it. Both of them, and let's create our new particle rain effect. All right, so create a new particle effect. Let's go ahead and rename it to rain, and let's bring it back. So Control-Shift-F, or again, Mac, Command-Shift-F, we'll rotate it. And in this case, we're going to rotate it so it's facing down rather than facing up. And let's go ahead and start off with our basic general module parameters. So let's change that start color. We can make it a little more blue. It looks like things are thinking on my end. They're slowing down a little bit. All right, and we're back. So let's go ahead and increase the start speed so that sits around 9. Even that's rain, it's gonna be coming out a little quicker than before. And the start lifetime we can pre-warm as well. We'll keep the start lifetime to about the same. That's totally fine. And then the start size, we'll keep the start size to about 0.2. So that we have something, rather than a large blue snowflake or a snowball, we'll have raindrops. Now, the important step here is to increase max particles to about 3,000, so we can really bump up the emission as well. Cool. So let's go ahead and increase that emission. Hop down to the emission parameter. We'll increase it so we have more of that torrential downfall. We'll increase that, let's just say for now, we can increase that to 500. Again, relatively arbitrary, but we found that to look okay. And now let's go ahead and update that shape. We're going to leave it as a cone, but we're going to decrease the radius to 0.1. Because when we said rain, we actually meant sprinkler. That's that's our goal for here. So now we're starting to resemble something like that screenshot, right? We have a very, very narrow output, so almost like a water leak or a sprinkler. All right. So now we need to update the renderer. So now let's start making this look like rain. And rather than keeping the render mode, and this is a new value that we're going to learn about, rather than keeping the render mode as billboard, we're going to do stretch billboard. So let's take a moment to pause on these different render modes. So by default, our renderer will render as billboard, which means that the texture will always, or the material, or the particle in this case, will always face you, which gives it its 3D look. These are really just 2D objects, by the way, but they will render more as 3D because of this billboard feature, because it's always facing you. However, how do we now stretch out the particles so that it simulates velocity or even acceleration or just general speed? We can use a stretch billboard to do just that. And we can stretch the billboard so that it's always facing you, so that it looks more like rain. Or we can stretch it horizontally, or have a horizontal billboard, so it's always rotated, and vertical as well. So a few different parameters for us to play with. So we're just going to use stretched so that it elongates the particle. And then let's go ahead and add our water drop material. So I believe there is something called water drop small. So we could either use water drop big or we use water drop small. All right. So we'll go water drop small, and then we are going to sort by distance. So the sorting is just a rendering feature as well. We have a few different sort modes, and this is just how the particles render over each other, which is most realistic if we sort by distance so that the closer particles render over the more distant particles. Great. Now, we're actually going to go into, and we're going to take a look at these vertex systems as well. So let's go and let's find the water drop small and make sure that we apply this required vertex streams to the particle, which gives us a more, to overly simplify it, it'll give us a more realistic look because of how the shader is taking in lighting data. Not right now, of course, because we have a few other parameters that we need to modify, but it will. Have faith. All right, so let's take a look. What's going on here? It's not quite right. It's moving quickly, so obviously I missed a step. Let's make sure our speed scale is increased as well. Cool. So in that case, let's just click around. Let's talk about what I was doing there. So the speed scale, we want to make sure that the speed scale is on so that we actually stretch in the direction that the water is moving. So let's move this down a little bit. Cool. So we modified the speed scale. What does that mean? Well, the speed scale, as defined here in our little helper, so it defines the length of the particle compared to its speed. So as the particle moves quicker, if we were to increase the speed of the particle, so would the stretch as well. And let's go ahead and test just that. So we have the speed, then this should, yep, we can see it stretching out significantly. So this isn't looking like rain right now, or certainly it's not looking like a sprinkler head, but it's starting to look a lot almost like a beam, a beam of light, say. So if we wanted to simulate, for instance, like photons, perhaps this could be an interesting tool to use. Well, let's go back. We don't need to go that hard there. And let's reduce that speed as well. Cool. We'll reduce the speed scale to, let's say, 8.2. Great. And on your own end, as I continue to play around with this and bring us closer to what the target image actually looks like, go ahead and tinker around with it yourself. So our goal right now is to is to create that rain or that sprinkler head look, or that hose head, if you will. We can increase the length scale as well. So again, this is just stretching it even further. I'm going to keep that color actually back where it was. I like that blue. You know, though this is less planned, see here that the rate over time is a little high. We don't need 3,000 there. We can bring that down just to 300. Those unplanned, this cone does look a little funky with rain, right? We don't need that. So let's go ahead and modify the cone shape as well. So that's coming out of the box, just like it was before. And now we have something that closer resembles a waterfall. So let's go ahead and expand this out. And again, what are we doing right now, guys? We're just playing around to achieve our desired rain effect. All right, I'm going to take a look at the chat really quick. All right, it looks like we're doing well in the chat. I'm going to reduce this length scale actually, just so that not quite as long. Oops. Keep the speed scale down at 1 as well. And continue to reduce the number of particles we're emitting at once. Great. Now it's starting to look a little better, but we can keep on modifying in our renderer. So what am I doing right now? I'm increasing the speed, start speed that is, and decreasing this length scale and the speed scale. Cool. So now we're starting to see something that looks a little more like rain. All right. Let me get. All right. So it looks like we are seeing some recommendations. Bojan just mentioned that start speed of 19, start size of 0.2, speed scale of 0.1 is starting to look great. So yeah, if you guys find something that looks really, really great, again, it does take some tweaking here. So if you find something that looks pretty nice, go ahead and just drop it in the chat. I'm sure other people would like to explore your effects as well. All right. So we have a little bit of time here. So let's go ahead and take a look at our planet examples as well. So I mentioned that we can create some planets, and this is relatively straightforward to do. We don't need any kind of textures, though. Usually we do like to add some kind of textures to get some kind of sun flares or anything like that. But how might we create a sun or another gaseous planet? Oops. Well, we can do so by modifying the emission shape. So we just completed the rain, so let's go ahead and close that down, and let's go ahead and create our last particle system. We're going to call this the sun. We'll bring it to the middle. And it actually doesn't matter the rotation of everything, because if we take a look at the shape, we'll keep the cone, or we'll modify the shape so that it's, instead of a cone, we'll use sphere. And now with a sphere, it's moving in different directions. Great. So with the flames, how do we keep the flame in just one spot? We reduced the speed. And let's go ahead and do that here as well. So let's go ahead and reduce the speed and make sure we're pre-warming as well, and reduce the lifetime. We can increase the start size too, and then increase the emission amount. So right now it's only 10. Reduce that lifetime to 0.2. We're actually going to bring that down. We're going to update so start lifetime should be around 0.1, and then the start color should be either yellow or orange, because again, we're creating the sun in this case. All right, and the simulation speed, let's go ahead and bring that simulation speed back to 1. Start speed, we're going back and forth here, I apologize. Start speed should be at 1 as well, or 0.1. Great. And now go down to your mission overtime. Let's crank it all the way up. Let's bring it up to, let's say 500. Not enough. Let's bring it to 1,000. Cool. And now we're starting to see something that more closely looks like the sun, but not really. This isn't nearly good enough. So let's go ahead and make sure our max particles are increased as well. 5,000. Right. And we can increase the size so that we're filling some of these gaps. You'll notice in these that there are some gaps there as well, so we can increase the start size to close that off. Cool. And we're going to reduce the simulation speed to something very slow because the sun is really large and is quite slow, or looks slow. All right, so now let's change the start color. So how do we create the effect of the sun's core being orange and the outside of the sun being more yellow? Well, we can do so by changing color over time, which, as you remember, we reviewed earlier. So toggle that on, color over lifetime. And in the beginning, we want the sun to be a red. And then towards the end, we want the sun to be more of that yellow. And once you start getting really crafty, once you start getting more crafty, you can add, you can duplicate the sun, for instance, and keep one sun inside of the other, so it looks more like a core. Say if you're creating some kind of atom or nucleus. And again, this is still moving quite quickly, so we can bring that down even more. We can bring the simulation speed down to say 0.001. Maybe that's a little too slow. Yeah, that's definitely going to be way too slow. But either way, we're now just tweaking everything. We're tweaking everything until we start to get an effect that we start to appreciate a little more, that look a little more realistic. Cool. So let's keep on playing around with the sun for just a few minutes. Before we do, let's take a look at the chat to make sure we don't have any questions. Yeah, so it's kind of a faux-handed painted look. Yeah, so in this case, we do need to have, because we're using the default particles as in the renderer, we still get that very fuzzy look. And if we wanted to make it much more accurate, for instance, we could add some kind of texture or another material. If we wanted to create, say, some kind of sun flares as well and have those coming off the sun, we could do so by creating, say, a mist or some kind of smoke texture. All right. So looking at a few other questions here. So what if you wanted to create water, but not as rain, but more like a lake or a swimming pool, or maybe underwater? Any advice? So first of all, we would recommend you using shader graph to create some kind of water effect. So if you wanted to create water, for instance, and you wanted to create bubbles in that water, then that would be a really, really great use of the particle system. You could create bubbles in a very similar way that we've been using it. For instance, smoke. It'd be the exact same workflow as you did with smoke to create those bubbles. Now, if you wanted to create waves in the pool, you wouldn't necessarily use particles. You'd use shader graph to create an animated shader. And we do have a live session on shader graph as well, where you learn how to move or animate a flag using a custom shader. So highly recommend that you come to that so you can get that waving back and forth. However, Unity's Learn platform does have quite a few tutorials on that flag shader. So I highly recommend you take a look at a few of those resources. All right. What else can we do here? A few areas before we start closing out. I'm going to hop back to the presentation in just a minute. So a few other key areas to play around with. You can emit particles from within other particles. So let's say we had a submitter. If we wanted to, actually, you know what? Before we start playing with our rain, we're going to emit rain out of a new particle. So how would we create particles, or why would we create particles out of other particles? Well, if you have some kind of trailing effect, right? You do have line renders that you can use that will emit out of the particle as well. If we take a look at trails, let's go ahead and do just that. Create another particle system. Let's say that you wanted to achieve that bug effect, or with the fireflies. And we could use this trail effect, and then we have these ridiculous these ridiculous lines coming out of the particle. And then we can go ahead and we can modify them as well. We can modify the lifetime of the tail. You can modify the actual size of the tail, how it stretches, the actual color as well, and of course the texture and material. So let's go ahead and kill that because it's distracting. And as I mentioned, we can emit other particle systems out of other particles. So let's say you throw, or you have a snowball hitting a wall, or let's say with the rain, for instance, you wanted to emit raindrops on collision. You could actually emit other rain particles out of each individual particle on collision. So that's one example of using collision in this case. But if you want other particles to move out of the particle, or the original particles for its entire life, then you can do so at birth, or set the parameter here to birth. And we can go ahead and choose which parameter to add. Oops, looks like that one was a prefab, so we can't use that. It looks like for whatever reason, it thinks that it's a prefab, which is quite peculiar. Just manually drag it in. Certainly strange behavior, but you start to see all of the particles emitting more rain. So that's how you would use these submitters. All right. So let's go ahead and close out from there. We're going to hop back to our presentation so you can see what other resources you have available. Reshare my screen. Great. So today we learned about particle systems. Particle systems, as you know, it's a very, very deep tool. And we're going to hang out here. We're going to keep on playing around with it for a little while longer, given that we have another 15 minutes. But if you would like to keep on learning more about, say, the terrain tool or other areas within Unity, we have these sessions every 2 weeks. So this next session is going to be about the terrain editor. So how do we use Unity's terrain tool to build out environments? Well, we'll have my colleague, Andy Jesvar, running that one on July 28th. So if you're interested in learning more about the terrain editor, the best practices for performance and the best practices for environment design, definitely come to that. And if you have any other questions, feel free to hop into our Unity Connect group. So that's this bit.ly link here, the Learn Live Connect group. And again, would love to continue the conversation. So feel free to reach out to me on LinkedIn. It's Tim K, LinkedIn, this bit.ly link at the bottom here. Always excited to continue the conversation around Unity. So again, we're a little early. We have about 15 minutes left in this session. So I'm going to hop back to the project and keep on playing around. And if you have any more questions as well, we'll keep an eye on that QA. We'll keep on answering questions for about another 15 minutes. But again, for those who are planning to hop off, thank you very much for coming, and we look forward to seeing you in the next one. All right, so we have one question here. How did you make the sun core effect again? So, Brian, I will go ahead and just demo that one more time. So the sun has a few things going on. Also, full disclosure, this is a very low fidelity sun. This is not, certainly not trying to pitch this as the best or the highest fidelity that Unity can achieve when it comes to creating planets out of the particle system. But given the assets that we have, this is just a quick little prototype. How do we get that core? Well, a few different effects that we're using. First of all, color over lifetime. So make sure that the color begins, or the particle begins almost as a red. And then as it finishes up its life, it turns into that yellow. We can make this a little more circular by tightening up the sphere itself. So the radius thickness and the radius itself. So now it's more of that circular shape. So what you can also do to create more of that core is just duplicate the particle system and reduce it in size. So now we have something that looks more like that core. So Jeffrey pointed out here in the next question that the sun seems to be pulsing. So if the sun is pulsing, it's creating a bunch of particles all at once. Take a look at the number of particles that can be emitted. So if we take a look at max particles, Unity will stop producing particles if it achieves the number of max particles here. So let's say we only had 10. Actually, let's go ahead and deactivate that second one so we can see this a little more clearly. This is going to be a rough demo, so I'm just going to start with a brand new one so we can see exactly what this looks like clearly. Great. So if you achieve the number of max particles you can, and what I'm doing here is just creating a new particle, increasing the rate. Let's do 1,000. And you may notice that you're starting to get these big bursts. And then it stops. So what's going on here? Unity emits up to 1,000 particles, and then it stops emitting particles. So we can either reduce the number of particles emitted, or we can increase the number of max particles. So let's boost up to 10,000. So now we can see that we have more of that effect, and this is really great. For instance, if we wanted to create some kind of like waterfall effect. We want to create a waterfall, for instance, we can reduce this angle. Now it looks like a very high volume is coming out. And if we wanted to create something with the gravity modifier and use physics, so the physics engine as well, we can increase the gravity. And then we can achieve some kind of hose or some kind of leak coming out of the wall. Great. So that's how you fix that pulsing problem. Okay, so James asked here, how could we go about having the train trigger a ripple on the ground? So again, the subemitters is how you do that. So you go to subemitter, where is it? Here it is. So as you create if we went into the rain, you could toggle on submitters, and then you could toggle on a ripple effect. Now you would have to set up that ripple effect as well. So it would be very similar to the sun in that there wouldn't be any gravity. It would just emit out from a circle, and it would just radiate out. You would need to have that ripple texture and material set up. So we're not going to do that right now. But you would use that submitters and set it from birth to collision, so that every time a particle collides, you could have drops fire off from it. All right, looking at some of the other questions here. So your case, changing the max particle. Okay, so following up with Jeffrey's point here, so changing the max particles doesn't remove the pulsing. So what you can do is take a look at the pre-warming as well. Let's make sure that the pre-warming is toggled on. So there are really only a few areas that might be affecting that. If it's pulsing out of the get-go, or out of the gate, I should say, from the get-go, then go ahead and toggle on pre-warm to make sure that everything's working properly, or rather to make sure that it's pre-populated or pre-rendered. Then look down at max particles and really boost those up. Boost them up to like a ridiculous number. Let's go to like 1,000. Let's go to 20,000. And then emission, make sure that that's bumped up. Those are the only areas that could really be affecting that. That would be creating that pulse. So keep on playing with those numbers if you're still not getting it. So you've added collision to, okay, so Dan's question here is that he has added collision to the rain, but it's folding to match the terrain before it even hits. It sounds like the time is off there. So go ahead and take a look at the start lifetime. And again, the start lifetime is responsible for determining the age or the amount of time in which the particle will survive or exist. So definitely take a look at that. Zoom in, see if it helps if you expand the lifetime. And if not, let's follow up, but we can keep on troubleshooting that. All right, Alessandro, your question here is, are there some settings that are particularly expensive in terms of performance, excluding max particles and emission rate? So again, the submitters is going to be really expensive, given that you could have an exponential increase of particles in your scene at once. So definitely be very, very careful with the submitters. Typically, if Unity crashes on me, or I should say when Unity crashes on me, it's because of the submitters in this case. Anything that has to do with physics, I know that's a very blanket answer, but if you're working quite a bit with, say with collisions, collision is if you have 20,000 particles emitting, they all hit the ground and they're all responding to collision, then that's going to be quite expensive as well. So Pierre Marie's question, would you use particle system to make clouds, or do you recommend something else? Well, a few different things. I have found I've made shaders before for the cloud effects, and then I just overlay them on a really large plane that I distribute, and then you can add certain types of animation as well. If you look at GitHub, you can find quite a few cloud shaders, so certainly recommend that you take a look at that. Now, if you did want to create some kind of cloud shader, a particle system, that's quite straightforward. You'd have to find the texture that you would want, but again, you could create an effect. You could increase the size. That's not. I'm not gonna demonstrate this and then just say that's what a cloud should look like. But you start getting an idea. You start getting an idea once you play around with the emission shape as well. So you could use a donut. So once you have the donut, you can really expand out that radius. in this particular case, it's very much going to come down to, and then of course increasing the time as well. So the speed and then the time. Let's see. Lift time. Here we go. So then all of a sudden you start to get, and I actually did a donut. We wouldn't do a donut. We would do a cone as well. So that they're all going in the same direction there. But again, you start to see how you could create something much, much larger on the scale of, say, your sky for your clouds. So certainly recommend that you play around with that. I would say explore shaders first. And if you need an excuse to play around with particle systems more just for your own learning experience, then highly recommend that you give it a try and see what you can come up with in terms of clouds. But you can start to see that how we can start to create some kind of angelic or cloud effect. All right, so it looks like Jeffrey actually got to the bottom of the pulsing, which is fantastic. That's great news. So we'll go ahead and close that one out. And then Dan, nope, we already hit that one as well. So cool. If there are any other questions, I am happy to answer, or I'm happy to demo any other tools in this. And again, if you need to hop off, no problem. Thank you all for coming. Hope you all enjoyed it. Hope you all had a few takeaways. But again, we'll be here for another 4 minutes. So one question here with Vibov is, any recommendations for roadmaps? Okay, can't recommend Unity Learn enough. So Unity Learn, again, is Unity's platform. It's the learning portal. It's free as well. So go ahead, register, make an account, hop in there, and there are a ton of beginner resources. Generally speaking, I highly recommend environment design first. So come to the next ULS, where we'll be learning about terrain. You just learned about particles. Soon you should dive into lighting as well. So start with lighting, start with sound, start with terrain, start building out environments. And then once you get a hang of the editor and you start feeling comfortable with all of the different editor environment tools, then start moving into the world of scripting, virtual reality, and augmented reality, and some of the other locomotion and interaction stuff as well. So start with lighting, start with environments, and then move into more customization, interaction, locomotion. All right. Does the particle system editor have any feature that we don't have in the inspector window? Pierre Marie, if you wouldn't mind following up on that. Mine certainly, if you're referring to the demo screen here, I have everything that you have access to as well. So the particle system editor, the inspector, you will have access to everything here. All right, so we're doing our 60-second countdown. If anybody has any final burning questions, go ahead and drop them in. We will get them as soon as possible. And if we don't get to them today, yeah, we have a few questions at the bottom there. So the original project template used for all this, this is in Unity's particle pack. So if you're in 2020 and you go into the asset manager, or if you are an earlier version, you go into the asset store, you can download their particle pack. They have a bunch of demos in there, a bunch of examples, and this is an environment taken from that pack. So it's just a Unity package. Alternatively, go into Learn Live, you can just download the assets and then you pull it all in. And this last question, will the particle system support Android and iOS builds as well? Yes, it will. That's one of the main advantages of it. So you can get particles onto any target platform. Whereas the VFX graph eventually will be supported by all platforms, but as of right now, I believe there are a few limitations. Awesome. All right, everyone. So we are at time. So again, thank you all for coming. I always have a really great job or a really great time running these. So appreciate you all hopping in. We will see you next time.